Hey guys, I hope you guys are doing good today. So, today we are going to talk about something on Unified Observability Platform. So, it gives you a lot of insight and knowledge. So, don't skip the video and please do watch this video fully. So, we have too many things around us. So, these many things that we have to monitor it. So, say for example, before having this SRE and DevOps, we may have each individual teams owning certain components. Say for example, OS team, they do take care of patching and they do an OS administration. They do take care of the VMs and PMs running in on-prem or cloud, whatever it may be. And database team, they take care of only the DB. MQ teams, they do take care of only the MQs. And parallelly, DevOps or SRE, they do take care of only the EKS cluster or Kubernetes cluster. Each team works on silos mode, right? So they do have different roles and responsibilities, and they do have a different kind of task they need to do it. And parallelly, they have to monitor their own components and their own service. So what exactly they have ended up? They ended up in having their own infrastructure and their own monitoring unified observability platform where exactly all the traces, metrics, and logs has to be ingest there, and then the SRE or business leader or whoever may be the responsibility of restoring that entire service could get a lot of information, and he can determine where is an issue and how, and then he can fix that issue. So that's the reason we are trying to bring about unified observability platform. Why we have chosen observability platform with open source technology? So observability is something, it always comes with the cost of SaaS products like Datadog, New Relic, App Dynamics, Dynatrace. So those SaaS based products, they charge us a lot. The ingestion rate is quite high, and parallelly, like some companies, some medium sized companies, they can't bear those costs. That's the reason they are having something with open source stack, so they can have a better retention. They do there a lot of sampling, they do a lot of processing, and then they can enrich the data, so they know what data has to go inside for the observability, what data is not required, so that I can take a clear and precise decision. Cloud infrastructure, and parallelly we do have something on on-prem on another end. So we have to pull platform related metrics, basically like infra related metrics, something like CPU utilization, memory usage, disk IO, whatever it may be. So we have to pull those metrics at any cost. Do you want to get more content like this? Then you have to subscribe my channel. Please do subscribe it. Prometheus is basically something like we can easily extract those infra related metrics. We have something called node exporter. So node exporter will definitely will pull those metrics, and our Prometheus in backend, it can scrap those metrics. NDM and NPM. So NDM stands for network device monitoring and NPM stands for network performance monitoring. NDM and NPM is core component in our observability stack. So basically we do have something in the network components, like in our on-prem environment, routers, switches, firewalls, and too many things around us, like say for example FI, LTM, and GTM. So as I said earlier, we will be using something on Prometheus. So we have to extract, or we have to pull that network components metrics, so that we can have a better visibility, like what exactly happening in the network layer, any DDoS attack is happening or not, what kind of request is landing, what is the request rate, what is the latency rate. So those things that we have to pull it out, right? So for that, we may need to have network device monitoring. So what we are going to do is right now here is like we are going to have something called SNMP exporter. So SNMP exporter is a component used in Prometheus to monitor the device and service that exposes via SNMP protocol, basically a simple network management protocol. It acts as a bridge between your Prometheus server and SNMP enabled devices, basically the network components. So it's translating the SNMP data into the format of Prometheus, can easily scrap. We have something called OpenTelemetry. So OpenTelemetry collector is the core component here in our observability platform. Basically, it receives the metrics, logs, and traces, and then it will process it. Basically, it will then enrich it. Enrich in the name, like it will rename your metric data, or you can filter only the certain type of logs has to go inside. You can filter your traces, and then it will export it to your different endpoints. Basically, logs, you want to move it to somewhere called Elasticsearch, and metrics you want to put it into the Prometheus, and then traces you want to put it into the Jigger or whatever it may be. You can export it to your multiple places. So that's the reason we do have an Otel collector. Otel collector will act as an agent, or you can have a centralized hotel collector, whatever it may be. Basically, I prefer to go for an agent, so it's better to use as an agent. So each agent you have to instrument along with your application service. So how you can pull your application traces or maybe metrics or logs? Obviously, you have to do something called the instrumentation. So there are two type of instrumentation here. One is called manual instrumentation, and another one is called automatic instrumentation. So developers explicitly adds the OpenTelemetry API. So basically, OpenTelemetry, it exposes certain SDK or API. So those you can download it from the OpenTelemetry website, and then you have to instrument along with your code. Basically, like you have to add the decorator or somewhere, and you have to import those SDK. And then once you follow the documentation, so you can start pulling the telemetry data of your entire application. Basically, if you look for the traces, it comes with the traces with a lot of parent and child span, and metrics, like if you're having something writing something a custom metrics, obviously it will get exported, it will get to the OpenTelemetry collector, and it will receive it, and then it will process and it will export it. So this is something all about the manual instrumentation. On another end, we do have something on automatic instrumentation. You have to just download your API or SDK, and then you have to run along with your code. Basically, you don't need to do any major changes in your coding side. Just you have to download an SDK, and then you just start your service, and then make sure your service is reading your library or not. So those things that it's already documented well in the website. Already instrumented our application service with Otel API or SDK, and then like application is started generating a lot of telemetry data, and then we are pushing those telemetry data to the Otel collector, and Otel collector is processing it something, and then like we are exporting to some places. So we are exporting to the tracing open source technologies like Tempo or Jigger. So it's up to you. I use something called Tempo. If you want to use the Jigger, you can use the Jigger. Have some comparison between Tempo and Jigger. So what exactly Tempo focus? Okay, it's focused on distributed tracing only, and it's optimized for storing a trace data at scale with minimal resource usage. It works seamlessly with observability tools like Loki for logs, Prometheus for metrics in Grafana ecosystem. So that's the reason I have chose for Tempo. Okay, what exactly the Giga does? It gives you comprehensive end-to-end distributed tracing solutions, and provides not only a tracing storage but also an advanced features like sampling, tracing, and visualization and root cause analysis. So this is the prime focus. Let's look into the architecture as well. It built for high cardinality and cost efficient storage. It does not require an external database. So this is the main thing that I have chosen the Tempo. The objects can get stored in S3, the Google Cloud Service or Azure Blob or whatever it may be. So basically the traces data, you can no need to store it into DB. You can store it into S3 places, and relies on integration with Grafana visualization. And Jigger requires the backend database, basically Cassandra or Elasticsearch or PostgreSQL, to store the traces data. And it includes its own UI for tracing, querying, and visualization. The integration and ecosystem is all about its native integration with Grafana for visualization for Tempo, and tight coupling with Prometheus and Loki for unified observability. Jigger is completely an independent tool integrated well with OpenTelemetry SDK, not tightly coupled with the observability tool like Tempo. Let's talk about something on scalability. It's completely designed for massive scalability, can handle trillions of traces efficiently in the Tempo, and gives a great for environment where cost and storage are the concern. And when we look for the Jigger is completely scalable, but heavily depends upon choice of backend storage, can be resource intensive. When to use? So when you can use the Tempo, when you can use the Jigger. If you are already using a Grafana, want a cost-effective, scalable tracing solution, then you have to go for the Tempo. And it is best suited for the high volume tracing with less focus on advanced analysis. Let's go look into the Jigger. If you need to have something called standalone tracing capabilities with a detailed analysis and with sampling option, then you have to look for the Jigger. and it is suitable for organization prioritizing advanced troubleshooting over cost efficiency. So that's all about Tempo versus Jigger, and you have to choose which tracing solution you want. It's up to you guys. Okay, now you have the traces. You don't have the metrics and logs. So you have to pull the metrics and logs. First, we will go with the metrics now. So how you can pull the metrics? You already have a node exporter. You already have an SNMP exporter. So node and SNMP exporter is completely the compromisable, and it will helpful for Prometheus to easily scrap. And OpenTelemetry also has something similar to Prometheus. So it has something called meter provider. Basically, you can write a lot of custom metrics about your service. Not only with Prometheus, you can use the meter provider with which is provided by the OpenTelemetry SDK. So basically, you can write a lot of custom metrics. It's completely depend upon how we want to use it. It both has a lot of pros and cons. It's up to you, like which one to choose it. So let's get into the comparison. Prometheus is already known by it's an open source time series database and monitoring system. It's ideal for short term and real term monitoring. So the main key feature for Prometheus is all about it's a pool based metrics collections built in query language called PromQL, and the data retention is typically limited as for days and weeks. Best use case for the Prometheus is all about it's best for standalone monitoring for single cluster or small environments. It's simple and lightweighted solution for the local metric storage. There are certain limitations. No long-term storage. Metrics are stored locally and purged after the retention period. No global views. Not designed for monitoring across multiple clusters or region. Okay, let's see what Thanos has. Thanos is all about highly scalable long-term storage solution built on top of Prometheus. Adds horizontally scalability and global querying capabilities. So there are certain key features like it has a global views, combines metrics from multiple Prometheus instance to have a unique view or unified view. Long-term storage, it integrates with object storage like S3, GCS or etc. for the durable metrics retention and downsampling. It reduced the storage cost by aggregating the older data, and it has an high availability features like ensuring a resilient metrics collection and querying availability. Use case is all about for environment requiring a multi-cluster monitoring or long-term retention for metrics, scalable Prometheus for large and distributed systems. There are certain limitations also here. More complex than Prometheus alone due to additional components like sidecar, courier, and a lot of things. Thanos courier, too many things are there. Let's talk about Mirror. Mirror is all about it's a cloud native time series database for high scalable long term metric storage. Originally developed by Grafana Labs as the Cortex, now it is evolved into Mirror. Key features is all about has a massive scalability, can handle millions of active time series metrics, multi-tenant supports, built-in shared environment in tenant isolation, PromQL compatibility, the retention policy, the high availability, and all those things it has. Use cases all about, say for example, organization is needing a multi-tenant enterprise grade metric storage or querying, so you have to go for Murmur only. It's suitable for the SaaS provider for large system requiring an extensive scalability. Limitations is all about more resource intensive compared to Prometheus or Thanos. Requires a deeper expertise to set up than maintain. So this is pretty complex, but it's good to go for it. Promptile, Loki, Elasticsearch, and OpenSearch. I will be choosing something called Loki here. So there are certain comparisons that we have to get into it. Promptile is all about an agent for log collection designed to work with Grafana Loki, similar to Logstash or FluentD, but it's tailored for Loki. The key feature is all about it reads the logs from the various source, applies label to logs for better organization in Loki, and pushes logs to Loki using an HTTP API. The main use case is all about Loki is primary log storage, and you need a lightweight agent to ship the logs. There are certain limitations. No log storage, act as a log shipper, tight coupling with Loki, not designed for other backends. So if you want to use Loki, and you have to consider the Promptile. So when you look for Loki, Loki is all about the log aggregation system optimized for scalability and cost efficiency, focusing on log indexing by metadata, basically labels rather than full text indexing. The main key feature is all about integrated with Grafana for visualization, and it has the query language called logql, minimal resource usage due to a metadata based indexing. Use case is all about ideal for environments where you are already using a Grafana for metrics and traces, and cost effective for large scale logging with limited full text search needs. There are certain limitations. Limited full text search compared to Elasticsearch or OpenSearch requires a PromptIR or FluentD for log ingestion. When you look for Elasticsearch, this is also pretty similar to the one. Basically, it's a full text search and analytics engine widely used for log aggregation, text search analytics. The main key feature is all about supports advanced full text indexing and search, integrates with Logstash and Kibana, scalable architecture with distributed storage and querying. It has a lot of good use cases, best for application requiring an advanced log search and analytics, suited for large scale environment with complex log queries. There are certain limitations, resource intensive and licensing problem will be there, so we have to mitigate those things. When you look for OpenSearch is all about like community driven fork of Elasticsearch only. It's created by AWS after they changed its license. Elasticsearch has completely changed its license now. It's a fully open search and backward compatibility with Elasticsearch 7.x. There are certain key features like it provides a similar functionality to Elasticsearch, like search and analytics and all those things. It includes the dashboard for visualization like Kibana. It supports the advanced the log search and full text and analytics. There are certain use cases. It's a fully open source alternative of Elasticsearch for organization. Avoid SSPL licensing. It's suitable for environment with complex log requirements and preferred for open governance. There are certain limitations newer than Elasticsearch, so tooling and ecosystem support may be less mature. You have logs, traces, and metrics, but you don't have something called profiling. So, profiling is a process for analyzing a program or system to understand its behavior and performance. It helps you to identify the bottlenecks, optimize the resource usage, ensure the efficient execution. This is essential in software development, especially for high performance or resource constrained applications. So, this is all about the profiling. Why exactly this is matters? It identifies the slow part of your code, such as inefficient of loop or database queries, and reduce the response times and improves your user experience. Basically, you can improve your performance by optimizing it. Resource utilization highlights the excessive usage of CPU, memory, and IO usage, helps in reducing the infrastructure cost, and it's completely scalable, ensure the application can handle increased load without degradation. And it helps you for the debugging. It pinpoints an unexpected behavior or issue like memory leaks or deadlocks. There are certain types of profiling like CPU, memory, IO, and database. A lot of things are there, right? So that's the reason we are using a profiling. We have to visualize these telemetry data into one single UI. So that's the reason I have chosen Grafana. So Grafana is one of the most important observability the stack. So we have to consider Grafana with open source stacks. Grafana is unified observability platform that provides seamless integration with Tempo or Prometheus or Mimir, Loki or Pyroscope. Together, they create a powerful stack for monitoring, for and then troubleshooting and optimizing the applications. Tempo with Grafana, why I have chosen is basically Tempo adds a distributed tracing capability to Grafana. Its benefit is visualize the trace directly in Grafana alongside metrics and logs. Basically, you can see the user journey. If something broken, so we have to get an alert. So how we can do it? So that's the reason we are using something called Prometheus Alert Manager. Prometheus Alert Manager is an essential component of Prometheus monitoring ecosystem. It is designed to manage alerts sent by not only by Prometheus server, too many endpoints that we can map it. It provides a powerful features for alert routing, grouping, silencing, and deduplication, ensuring the alerts are handled efficiently and notified to the right team at the right time. So that's the reason I have chosen the Alert Manager. Keep There are few key features that we have to consider it. Alert routing, it's already known for you can route alerts to a different destination based on label, severity, other criteria. It can routes can be directed to notification channel like Slack, PagerDuty, email, or custom webhooks. It allows multiple receivers, grouping of alerts, making it easy to manage and prioritizing. There are certain things like alert grouping. You can group related alerts together, reduce your alert noise, ensuring they are received as single notification, helps prevent you the alert storms where multiple related alerts are fired at once and providing a clear insight into root cause of the issue. Alert deduplication prevents the duplicate alerts from being sent when the same issue is detected repeatedly within a short time frame. Reduce the unnecessary notification spamming and makes alerts more manageable. Alert silencing, you can allow the temporary silencing for specific alerts, such as during a planned maintenance or known issues or avoid unwanted notification. And so these alerts for from known or unexpected events don't trigger unnecessary action. Alert inhibition basically prevents an alert from firing when another critical alert is active. Example, you can inhibit alerts for non-critical issues if a major system is failure is already being handled and reduce the alert fatigue. Highly customizable. That's the reason I have chosen for the Prometheus Alert Manager. So how exactly this works? Prometheus generates an alerts based on defining an alert rules. Example, CPU usage exceed the threshold. These alerts are sent to alert manager. Alert manager process the alerts based on configured routing rules, grouped them and deduplicating them if necessary. And notifications are sent out to specific channel, ensuring the appropriate team members are notified based on the severity on context. Unified Observability Platform for monitoring on-premises and the cloud services. The node and SNMP exporters collects data from on-prem systems and the cloud service. The OpenTelemetry collector process and exports the data to tools like Prometheus, Loki, and Tempo. The Grafana provides a centralized dashboard for visualization and alerting, while Alert Manager forwards the alert to the incident management systems and chat tools or email or SMS. The platform ensures the full stack monitoring and actionable insight. Do you want to get more content like this? Then you have to subscribe my channel. Please do subscribe it.